Okay, the next part of question 9 has got the equation for the reaction that we were just talking about, and it gives you some information. So it starts off by saying you've got 20.1 moles of carbon monoxide and 24.2 moles of hydrogen placed in the sealed container. An equilibrium was established at 600 Kelvin. The equilibrium mixture contained 2.16 moles of methanol. Calculate the amount of moles of carbon monoxide and hydrogen in the equilibrium mixture. So to do this, I'm going to go to my rice table. So my ratio of carbon monoxide is 1 to 2 hydrogens to 1 methanol. Okay, so my initial moles of carbon monoxide were 20.1. My initial moles of hydrogen were 24.2. My initial moles of methanol were none because the reaction has not started. And I need to check that, so just check the question carefully whether or not it's an established equilibrium and something was added, or whether the reaction hasn't even started yet. So this question, the reaction's not started yet. So I can say that I've got 0 moles of my product before I begin the reaction. So the change in moles. So I'm going to work that out actually after I've added a bit of information about my methanol. So my equilibrium mixture, I've got 2.16 moles of methanol at equilibrium. So my change in moles for my methanol, it's gone up by 2.16. Okay, so to work out my change in moles for carbon monoxide, I must have taken away 2.16. So that's in the same ratio 1 to 1, so I don't need to do anything to that 2.16. However, my hydrogen is in a 2 to 1 ratio, so I need to times that 2.16 by 2. So that becomes 4.32. So my hydrogen will have gone down by 4.32. And then to work out my equilibrium moles, I just need to essentially do 20.1 take away 2.16 to get me 17.9. And then 24.2 take away 4.32 gets me 19.9 to the right number of significant figures in the question. So my carbon monoxide moles 17.9 and my hydrogen moles 19.9. So 1 mark for each of those. Okay, so moving on to the next part of this question, I've got a different mixture of carbon monoxide and hydrogen. It reached an equilibrium at the same temperature, but it's a different equilibrium. The equilibrium mixture contains 2.76 moles of carbon monoxide, 4.51 moles of hydrogen, and 0.360 moles of methanol, and I've got the total pressure 630 kilopascals. Calculate a value for the equilibrium constant Kp for this reaction and state its units, 6 marks. Okay, so I'm going to start off by rewriting out my equation. So carbon monoxide plus hydrogen is going to make methanol CH3OH. So there's my equation. That's going to allow me to write an expression for Kp. Kp is equal to the partial pressure of my product, which is CH3OH methanol, divided by the partial pressure of carbon monoxide, multiplied by the partial pressure of hydrogen squared, because I've got that 2 in front of the equation there. So 1 mark for writing that out. So again, for these questions, it's always worth doing what you can do and working that out. What I'm then going to do is I'm going to work out the total moles of gas at equilibrium. So this is given from these 3 numbers up here, 2.76, add 4.51, add 0.360, gets me 7.63 moles of gas. And again, I'd get 1 mark for that. So I've got 2/3 of the marks just for writing an expression and adding up the number of moles of gas that I'm going to use. Then what I would do, once I've got the total moles of gas, I've got the total pressure, I can work out the mole fraction for each of my gases in my equilibrium mixture, and I can work out the partial pressure exerted by those gases. So the partial pressure for carbon monoxide is going to be my 2.76 moles that I've got, divided by my total number of moles, 7.63, multiplied by the total pressure, 630, gets me 228. So the partial pressure exerted by carbon monoxide is 228 kilopascals. I can do that for my hydrogen. So at equilibrium, I've got 4.51 moles of hydrogen. I've got my total number of moles, 7.63, times that by the total pressure, gets me the partial pressure of 372 kilopascals. And then I can finally do that for my methanol. So the partial pressure of my methanol is the mole fraction, 0.36 over 7.63, multiplied by 630, gets me 29.7 kilopascals. These three partial pressures should all add up to 630. I'm just doing a quick check. They look good, so that's something you can do to check your work. And the mark scheme says if you worked out all three of those, you get 2 more marks. So you get 2/3 of the marks for doing what we've done so far. What I'm then going to do is I'm going to add those partial pressures into my expression for Kp. So that's 29.7 divided by 228 multiplied by 372 squared. That gets me 9.4 times 10 to the negative 7. That gets me 1 more mark. And then I need to work out my units. So I'm just going to put my units up into this expression up here. So kilopascals, 1 kilopascals on the top, and then 1, 2, 3 kilopascals on the bottom because we've got 1, 2, and then another one because we've squared it. 2 of them cancel out, leaving me 2 lots of kilopascals on the bottom. To get them up to the top, I need to do kilopascals to the -2, and that gets me my final mark.